this function is undefined at positive and negative pi over 2, it will have a vertical asymptote at those points. And now the reverse is that this function will have horizontal asymptotes at pi over 2 and negative pi over 2, because tangent looks like this. It has vertical asymptotes at negative pi and pi. So then now the arctangent will have horizontal asymptote at negative pi over 2 and horizontal asymptote at pi over 2. This again is to remember. Please. So up here, I have y equals pi over 2. Down here, y equals negative pi over 2. And here comes the graph. This is the graph of arctangent x. So a question now, if x approaches infinity, what value does this function approach? Juliet?
In which function, like which value are you talking about?
Okay, so when x approaches infinity, this function approaches a number. Which number?
Infinity also.
It has a horizontal asymptote, and it's going asymptotically closer and closer to pi over 2. It cannot do this. So the function is doing this. Cannot go up there. It has a horizontal asymptote. It has to stay between these asymptotes.
That's true. Okay.
Better?
Yes.
What about when x approaches negative infinity? Let's say Josh. The arctangent will approach
negative pi over 2.
Right. This is very important for chapter 2. That's why I'm doing this. And moving forward. Okay. Any questions about this function? We must remember its graph. Okay?
Just to be sure, this was the graph of arctangent.
Yes.
Okay.
Very good. Moving on. I like to establish these graphs, or have these graphs in our minds so that we don't have to go back all the time. So here it is, f of x equals e to the x. What type of function is this?
Exponential.
Very good. You understand why it's exponential? Because the variable is the exponent. The base is a number. This is not a variable. This is the variable. That's why it's called exponential. The exponential function is what I never thought I would say to my students, is what we are experiencing as we live together right now in our lives. This is this insane virus. So few people get infected, and then 3 days later, it's 10 times as much. And then 5 more days later is 1,000 times as much. So that's what they're talking about when they say, okay, let's flatten the curve if we can, or at least flatten the curve if we cannot just bring it down. This is the fastest possible growth. Insane. Okay, so this is the exponential function. Now, if I ask, what is its domain? Let's say Mickey. What is the domain of exponential function? Is it friendly or not?
All real numbers.
Friendly. I like this function. Not as much now. Perfect. Can anyone give us the range of this function? Ian.
Everything
greater than 0.
Thank you very much. With the parentheses 0 to infinity. Great job. And as you see, it's increasing on all its domain. Finally, as x approaches infinity, where does this function go? Isaac.
Sorry, what did you say?
As x approaches infinity, I just want to make sure you're not forcing grandma to sit there and answer questions. No, okay. So when x approaches infinity, the function approaches
So there's so much noise. Sorry, can you repeat that?
Sure. As x approaches infinity, where does the function go?
There's infinity.
Very good. As x approaches negative infinity, where does the function go?
Towards negative infinity.
It will go like this then. This is a horizontal asymptote. Y equals 0 is the horizontal asymptote. So where does it go as x approaches negative infinity?
It doesn't go below 0.
Great, it goes to 0. Okay, moving on, one more function, f of x. So this is to remember. So we remember this graph, we remember the end behavior, okay? And the x-intercept for a pure graph, pure exponential function is always 0, 1. If I put here +3, it's not going to be 0, 1. If I put -5, it's not going to be 0, 1. But if a pure exponential, it will always cross at 0, 1, the y-axis. Okay, last one, natural log x. Okay, so question about natural log x. Where is natural log defined? RJ.
You said natural log?
Yes.
Would that be just log of E?
Okay, so let's talk about this. Exponential function, we already discussed that, is defined on all real numbers, and it has range 0 to infinity. So exponential function will go from negative infinity to infinity to 0 to infinity. This is for the exponential. Natural log is the same situation, tangent and tangent inverse. These are inverses of each other. So the exponential e to the x and natural log x are inverses of each other. So then what would be the domain of natural log?
So the domain would be 0 to infinity.
Of course. And its range will be?
Negative infinity.
Right. So always keep that in mind. If we said here the domain was between negative pi over 2 and pi over 2, then the range has to be between negative pi over 2 and pi over 2 for the inverse function. So therefore, the exponential is defined on all real numbers and having values on 0 to infinity. And natural log is defined on 0 to infinity. I'm making a point because this has to be remembered. Remember. So then the graph is symmetric with respect to y equals x. The graphs of the function and the inverse have to be symmetric with respect to the line y equals x. So here's the graph. And of course, it has to cross at 1, 0 because this one crosses at 0, 1. And this is natural log x. Both increasing on their domain. If the exponential is increasing, its inverse must be increasing. If the function tangent is increasing, its inverse is increasing. on all its domain. Okay, and now the question is, Leo, when x approaches infinity, where does natural log go? Leo, are you there?
Hi, I'm right here.
Good. When x approaches infinity, yes,
Goes to infinity, doesn't it?
exactly. And Sarah, as x approaches 0 from the right, because there is no 0 from the left, 0 from the right, where does the function value go? Where do the function value go? Sorry. Or where does the function? Yes, indeed, negative infinity, which obviously means that x equals 0 is a vertical asymptote. Makes sense. This has a horizontal asymptote. The inverse must have a vertical asymptote. The function tangent had vertical asymptotes. The inverse has to have horizontal. Okay, enough of that. Please remember all these graphs so we don't have to go back to them. We need them like that in a blink of a second or a moment, okay? Now I would like to look at the piecewise defined function, and then we'll hopefully try to finish that in the next 25 minutes. Okay, so here's a piecewise defined function. What is a piecewise defined function? A piecewise defined function is a function defined by different functions. It could be 2 or 3 or more. So an example will be, let me switch to my video so you can, my camera so you can see me. So an example of a piecewise defined function is the tax code. That's a perfect example of a piecewise defined function. For people earning between A and B, there is a function. Between B and C, a different function. Between C and D, a different function. In other words, a different percentage. Or a function that is, it could be even differently calculated, okay? So these functions will never overlap. So I'm going to switch now. So if you graph a piecewise defined function like this, let's say it's a quadratic, and then you graph on top of it a linear function. This is terrible. This is not even a function. So a piecewise defined function could look like this. Let's say this is one piece. Let's say this is a different piece. And let's say this is a different piece. Blue, green, and red. They cannot overlap because this piece is on negative infinity to this number. The green piece is between these two numbers, and the red piece is between this and infinity. You cannot extend the red piece, you cannot extend the green piece, and you cannot extend the blue piece over the territory that is blue, green, and red. So something like this will be absolutely terrible. It means that a student who writes something like that did not understand what a piecewise defined function represents. Okay? It has to be a function, first of all, and this would not. Okay, so now, keeping that in mind, I'm going to copy this problem. Which page am I on? I talk too much, I know. Okay, here it is. So this is f of x, and it has three branches, three pieces, x less than or equal to 0, 1 minus x squared between 0 and 2, and the square root of x plus 5 for greater than or equal to 4. So this is a piecewise defined function. It has three pieces. We haven't graphed it yet, but it has to look something like this. So then when you draw a vertical line, it will of any vertical line will hit the graph in only one point or none, but not two. Here, when I draw a vertical line, it crosses the blue and the red, and that's not a function. Okay. First, we have to identify the domain. Every time we graph a function, we have to identify the domain first. Okay, I would like to change this, and I think I said that several times already, but I'm going to say it again. If you prefer a different method, you do not have to learn mine. If you think that mine is easier, please adopt it. If you have your own that works and it's easier for you, use your own. So, if you don't have a game plan for this type, please follow my lead. Okay, so can anyone give us the interval notation for this? Sarah, can you tell us the interval notation for this?
Would it be negative infinity to 0 with a bracket?
Awesome. Great job. Okay, can anyone tell us the middle interval? Let's say Mark. I don't know if I asked you, Mark.
Hello.
Hello.
Let's see. Positive infinity.
We are talking about x between 0 and 2.
Oh, the x.
We are talking about the middle branch. Zero to 2, correct? Which part of my question is not clear?
I'm just trying to compare it to the top one and the bottom one.
This is x less than or equal to 0. This is not the bottom. We are talking about the middle part now. So less than or equal to 0 means negative infinity to 0. X between 0 and 2 means 0, 2.
Okay.
And what about the last one? How do we change this in interval notation?
Positive infinity 4.
But it says greater than or equal to 4, and we have to write from left to right. I cannot write positive infinity to 4.
Right the other way, 4 positive infinity.
Yes. Yes. I'm not saying it's wrong, but we have to write them in order, from left to right. Good. So now can anyone tell us the domain of this function?
It would be negative infinity to 0 bracket, and then 0 to 2 soft brackets or parentheses, and then hard bracket 4 to infinity.
But since 0 is here, but 0 is not here, can I write negative infinity to 2?
No, you can't do that.
No.
Why not? So negative infinity is 0, union 0 to 2, it means negative infinity to 2.
You can't connect them though, right?
I'm talking about the domain of function f. I'm not talking about anymore. It's a very good question. I'm not talking about the domain of this and the domain of this and the domain of this. When we talk about the domain, we're talking about the domain of the entire function. So there is no gap between negative infinity and 2. Everything is here and everything is here except 2. No gap. Union. Tamara?
Sorry, just me. Okay, so negative infinity, 2, union 0, 2.
I already included 0, 2. So negative infinity 0, union 0, 2 is already here.
Oh, got it. So then 4.
Perfect. Is that clear, everyone?
Yes.
Okay, our table. Okay, so I'm going to write negative infinity. 0 has to be in the table at all times, and especially now when something important happens here, it changes from, the function changes from 2 to 1 minus x squared at 0. Okay, 2 has to be in the table, and 4 has to be in the table, and infinity has to be in the table. Now bear with me and please pay attention, and you'll understand this. It's very easy. At 0, I see a bracket facing left, and also at 0, I see a parenthesis facing right. Immediately under 0, I will write these two symbols touching each other in the exact same direction as I have them in the interval notation. I have a bracket facing left and I have a parenthesis facing right. And these are at 0. At 2, can anyone tell us what are we going to write under 2? Carson. I couldn't hear you.
Can you hear me?
Yes, now I can.
Would it be a parentheses facing left and then a bracket facing right?
I don't have anything. I don't have a bracket facing right at 2.
Oh, would it be another parentheses then?
Nope,
Facing right?
it will be nothing. And it will be a bracket at 4 facing right. There is a gap. There is nothing I can plug in between 2 and 4, and I cannot even plug in 2. At this point, we will establish the function on the table, just to make sure we don't make a mistake. For x values between negative infinity and 0, which is the function? Can anyone read the function for us?
If x is less than or equal to 0, then
Cool.
it is 2.
Exactly. Between 0 and 2, can anyone read the function for us?
One minus x squared.
And I know it's silly to wait for that. It's very clear for everyone. It's x plus 5. Okay, perfect. Okay, we are looking at, these are my props. We are looking at negative infinity 0. I have to plug in some numbers here, but this is a linear function. I only need one number. I'm going to say negative 2. When x is negative 2, what is the y value? 10, will you tell us?
The y value is going to be 2.
Good. When x is 0, what do I write right inside the bracket?
Inside the bracket, you would also write this well. 2 as well.
Very good. Excellent. We're done with this branch. We are talking about 1 minus x squared now. Nothing else matters. Okay. So the next step. I want to plug in 0, and I know you will say you can't. And I will have to agree with you. I cannot plug in 0 here. 0 is here with the equal symbol. 0 is not equal here. But bear with me and tell me what happens if I plug in 0. Because if I don't plug in 0, I will have to plug in 0.000000001. So can anyone plug in 0 for us and tell us what to write inside the parenthesis?
I think I got lost at negative 2. How did you get negative 2?
I picked any ordered pair, any x value between negative infinity and 0. If you don't like negative 2, let's try negative 1. It doesn't matter, as long as it's between negative infinity and 0.
Okay, so you chose negative 2 and you plugged it
Into the function. That's why I wrote it above here, so I don't have to forget. I don't have to go back to that. There is nothing you can plug in, because there is no x.
I'm not quite getting that part.
So if x is negative 2, how much is y?
2.
If x is negative 1, how much is y?
Where am I plugging it into?
Exactly, you don't have anything to plug in because there is no x. Correct.
Okay, so would it be 1?
How can it be? The function is 2. No matter what I plug in, the function is 2. Is that better?
Okay, sure.
When I plug in 0, I don't have anywhere to plug it in. The function is y equals 2, which is a horizontal line, no matter what. No matter what I plug in, it's 2. Better, everyone? Okay, let's plug in 0 on the other. What do I get inside? 1, very good, right inside a parenthesis. Let's also plug in 1, because it's a key point.